We're taking a look at your frequently asked homework questions for homework 5.10. So the first question I'm seeing several of you ask is number 15, which is an application problem. Number 15 tells us that we have a projectile that's fired straight up. It gives us an equation and tells us h is the height and t is the time. So t is where x normally is. So our x values are representing time, and the y values are representing height. So at a certain time, what is the height? And notice that this is a parabola that is opened upside down. If you think about it, the c value is 0, so it looks something like this. And that's all that would apply for us. We're only dealing with positive time and positive height, or 0 time and 0 height. So this says find the time the projectile will need to reach its highest point. Well, this highest point will be the vertex. So this question's really just saying find the vertex, and there's all kinds of different ways you can do that. You can complete the square, you can graph it on your calculator. I'm going to go ahead and say my x value of my vertex, which would be t here, I know I can find by taking negative b over 2a. So negative 40 over 2 times negative 32. And so I'm going to type that in my calculator. And I'm getting 0.625, and that is going to be in seconds. So that's when, at what time it reaches the maximum height. Then it asked me to find that maximum height. So in order to do that, I'm going to plug in 0.625 into my function. And you're getting 18.75 feet. I'm going to take a look at number 10, and I will tell you, I believe on number 10, you just made this problem probably a lot harder than it actually is. So I'm first going to start by just simplifying things. And so I see I have an I cubed, which I know is I squared times I. I squared is negative 1, so this is actually negative I. Which means I'm going to have 1/3 plus negative 6i. Okay, then I'm going to come here to I to the 6th. Well, it's I to the 4th times I squared. I to the 4th is 1. I squared is negative 1, so I end up getting negative 1. So that makes it negative 1/2 minus. The square root of 1 is 1, square root of 25 is 5, and when I have a negative, I can pull an I out. So see, once you simplify, this is actually just a subtraction problem. I'm going to distribute my negative. And I have negative 1/3 plus 1/2. Those are my like terms. And then I have negative 6 plus 1/5 I. So I could get a common denominator. So negative 2/6 plus 3/6 is positive 1/6. And then I would have negative 30 over 5 plus 1/5 I. Oops, I forgot my I all the way down through there. And now we have negative 9/5 I. And there's your answer. Just take it piece at a time. Next, we're going to look at number 14, which says you want to create a flower garden. You have enough flowers, and it's the shape of a rectangle. You want to create the largest garden possible, so we'll call this length and width, which means area can be represented by L times W. We're also given that we have enough flowers to make 700 feet around the outside. So that means 2L plus 2W will have to equal 700. So we're asked to maximize area, and the issue we have here is this equation has too many variables. So I'm going to pick a variable in my perimeter equation to solve for. It does not matter which one. So I'm solving for L. Which means I'm going to come to my area equation, and every time I see an L, I can plug this W in. Okay, well, let's multiply that out. You have a quadratic. We know that this is quadratic turned upside down. We also know the y-intercept is 0. And I want you to think about what variables we used. On this quadratic, on this parabola, every x is representing a width and every y is representing an area. So we want to find the maximum area. We want to find the maximum area. So that means we need to find the vertex. Now we can do that several different ways. In the above step, we were given the factored form. We know this is 350. We know this is 0. We could find the middle to find the x value of the vertex, which is the width. We could do negative b over 2a. That's going to give us the x value of the vertex, which is the maximum width. So there's several different ways that you can do that. It doesn't matter to me which way you do. But the middle of 0 and 1 and 350 is 175. So you actually now know the maximum width. If you were then asked to find that maximum area, you could just plug 175 in. You're finding the y value of that vertex, which is 30,625. If you want to find the other dimension, okay, put it in here. You know the width now. The width that you're wanting is 175, so you can plug that in. I believe you're going to hit 175 again. So the max area is 30,625 square feet when we have 175 feet by 175 feet. A couple of you asked about number 7. I did leave an answer off the answer key on number 7. One of the nice things about number 7, it's already factored. So I know by zero product property, I can set each factor equal to 0. And by the way, this should have 1, 2, 3, 4 solutions here. So when I work this problem, it should have 4 solutions. 2 of them are very straightforward to find. I can see x equals negative 11, which is the one I left off the answer key. X equals negative 3. For the other, it is a quadratic. I can either use quadratic formula. This is one I can extract the square root. So I'm going to subtract 2. Take the square root of both sides. That leaves me with the absolute value of x equals I root 2, which leads me to a piecewise. So x equals I root 2, and x will equal negative I root 2. So notice, I'm getting 4 solutions there.